Hello guys, today we are going to solve this fourth order non-homogeneous differential equations. And you can see there's psi x on the right hand side. The coefficients is psi x. And then we are going to, whenever we are going to do a non-homogeneous differential equation, first we are going to find the characteristic solutions. Yes, characteristics equation, I'm going to write this as m power of 4 and then plus 2m squared plus 1 is equal to 0. We are going to find the homogeneous solution to this first, yes. And we can write this for m power 4 as our m square square, and then plus 2m times 1, and then write this as our 1 square. You can see this easily our a square plus 2ab plus b square formula. So therefore this is our it should be m squared here as well, and then this should be m squared plus 1 square is equal to 0. Whenever you have a 0, we are going to take a square root on one side, and then you have a plus or minus 0, which is just 0, and no that. And then you can get m squared is equal to 1. Negative 1 it should be. First we are going to take a square root on both sides. You can get m squared plus 1 is equal to 0. Therefore m squared is equal to negative 1, and then take a square root plus or minus side, right? Therefore you can get square root of 1, which is I. Therefore you can get plus of minus I. However though, we have something like this. Something square is equal to 0. Whenever we are going to do this situation, we are going to get a repeat root. Therefore I'm going to label it as our double roots here. Whenever you are going to get a double root, first you are going to write down the original one, 0 plus or minus I, which is e power of 0x times cosine c1 cosine x, right? c1 cosine x plus c2 sine x. This is a formula. We can just remove this e power of 0x because it's just one time this entire thing. First you can get the first solutions, and then because we get a double root, we are going to multiply by x. Add another solutions, which is c3 cosine x plus c4 sine x, and then we are going to multiply by x here. And then we can just factorize the c cosine x. Therefore you can write this as cosine x and then times c1 plus c3x and then plus sine x times c2 plus c4x, like that. This is our complementary solutions to this differential equation. And here we are going to use our inverse order, yes, inverse operator method. We are going to write this as d power of 4 plus 2d squared plus 1, because this is the 0th derivative, and then times y of p. Remember to write down the y of p because you are going to deal with the particular solutions. Label it as yp, and then which is equal to sine x, and then we are going to divide it by this expression on both sides, which is 1 over d power 4 plus 2d squared plus d times sine x. Whenever you are going to do a sine x, we can replace this d squared with our negative k squared. The k, which is whenever you are going to deal with sine kx or cosine kx, we can replace d squared as our negative k squared in this expression. And then here sine x, which is sine 1 times x, which is our d squared, which is negative 1 squared here, which is negative 1, and then d power 4, which is negative 1 squared, right? D squared squared, which is 1, right? Therefore we can replace this with our 1, and then d squared, which is negative 1, and then you can get negative 2, and then plus 1 sine x, like that. However though, you can get 1 plus 1, which is 2, and then minus 2, which is 0. Whenever you see a 0 in a denominator, we are going to do the derivative on the denominator. Do the derivative of d power 4 plus 2d squared, and then I'm going to write down. Do the derivative and then multiply by x. This is the rule. whenever the denominator is 0, you are going to multiply by x on the top. Therefore, you can get something like x times 1 over, and then do a derivative, you can get 4d cubed plus 4d plus 1 sine x. Yeah, and then whenever we put a 1 here, 4 times 1, d cubed is d cubed. Wait a minute, because this is d cubed, we can write this as 4 times d squared plus 4d plus 1, like that. And then whenever you replace this 4d, right, with our negative 1, this 4d and 4d get cancelled. However, you cannot do this. You cannot do this because you can get negative 4d and then cancel out the solutions. But this is not going to work. Whenever you cancel out the 4d and then you just get x sine x, right? Your answer is wrong because you already get an expression x times sine x in the complementary solutions. This is the repeating solutions. Therefore, we cannot do this. Therefore, we are going to take the derivative once again. The denominator derivative once again. Therefore, you can get x squared times 1 over 12d squared plus 4 plus 1. Just 4, like that. And then whenever you put a negative 1 on the denominator, this, finally, you can just get our negative a, right? Negative a sine x. Therefore, you can get our particular solutions to this, which is equal to negative 1 over a x squared sine x. You can see this x squared here, and no longer repeating the expression x sine x here. Therefore, this is the correct solutions. Therefore, our y is going to be this entire expression, cosine x times c1 plus c3x plus sine x times c2 plus c4x, and then minus plus negative 1 over x squared sine x, like that. Therefore, this is our solutions to this fourth order non-homogeneous differential equation. Yes, really crazy looking differential equation, but this solution is really nice. How you can get x squared times sine x. Because of the repeating situation, you have to multiply by x. And this video is over, and bye. Stay tuned for more quality videos.